Hello, welcome to today's webinar on transforming customer experiences with AWS container services. Today we'll be going through sort of the basics of what a Docker container is and how does it work, why do people do it. It's obviously something you've heard about, or I'm assuming you wouldn't have joined today's webinar, so it's something that's very relevant today. But of course, when you're talking about public cloud and particularly AWS, there's a lot of questions that probably come to mind. So I'll go ahead and get started, but first I'll introduce myself. My name is Seamus Owens. I'm an AWS solution architect. I work here at Rackspace, working with customers who are either working in containers already or are looking to make the move and want some guidance in terms of gotchas or cost considerations, or just there's a lot of questions. So that's my role here at Rackspace, and I'm certified in AWS and Azure, but I really focus on the AWS side of things, and I'll be talking specifically around AWS services today. So why do people want containers, right? I've got a couple of high-level introductory slides. If you're already well on your way to containers, then you probably already know. But if you're not, and you're wondering what it's all about, then it's a political question, right? There's lots of reasons why. When VMs first came out, there was a lot of debate about whether a VM was actually better than a physical server. I think it's pretty obvious what the answer is in most cases. But in the same case with containers, there is question about whether it's worth going to containers, and sometimes that's a question that's worth asking, right? It's not always the right call. But the reason people are going in that direction is because it alleviates a lot of pressure or a lot of standard obstacles that developers often have to deal with, which is how can I ensure that what I'm working on day to day on my MacBook Pro is going to work exactly how it's going to work on an Ubuntu server in AWS, right? I mean, people spend a lot of time figuring that out. It is there's all sorts of smoke tests, unit tests, everything to try to figure out why something would work locally but not work in the cloud, right? So one of the major items in container workloads is accommodating the developer and ensuring that you have an even playing field between what's running locally on your MacBook and what's running in publicly on a web server. Okay, so Docker supports virtually any operating system, but the point of a container is actually to get away from the operating system, to focus just on the application code, the underlying libraries, your requirements, the basic components of your application, which are going to be really specific to you and what you use to develop your app. So first thing is, what is a container? Again, if you've been through some of these before, it's probably annoying, but I am going to go through it because it is important to kind of peel back and talk about what it is and why is it different from everything else that we've come across before. And I'm going to read it long, but the last sentence is really important. So a container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. Okay, fine. A Docker container image is a lightweight, standalone, executable package of software that includes everything needed to run an application: code, runtime, system tools, system libraries, and settings. So that's really important, right? It's lightweight, it's standalone, and it's an executable package of software. So lightweight, first of all, it's back to what I just said, right? You can run it. You're developing in your basement, right? You're developing on the same computer that you run Spotify. Maybe you're mining for Bitcoin, whatever, right? It's lightweight. It's not going to impact the other processes, applications that are running, because it's not designed to, unless the container itself is the application itself is a power hog. The shell for the container is very lightweight, and again, that makes it great to run locally. It's also standalone, which is similar to the point I just made, which is you don't need to have a server grade enterprise-ready grade hardware to run a container. You need an operating system. You do need that. You need a computer. You need an operating system. But aside from that, there's not a whole lot of other dependencies, right? And that's kind of the point. The last is that it's an executable package of software that includes everything needed. So that's what we're going to talk a little bit about. You have to include in the container, obviously your code, got to be copied in the container. You've got to delineate the runtime, what version of Python or Node or whatever you're using do you want to include as part of your application, and then all the other dependencies, right? Are you using a particular version of Jinja, or are you using a particular version of Postgres or Flask modules or something like that, right? So it's also not a container or a retainer, often confused, but I won't spend any more time on that. All right, Containers 101. So this is an infrastructure picture, a little hard to get, and it's not that useful, but it's worth talking about because it does show how it differs from the past. So on the left was kind of the slide probably that everybody used to talk about what is a virtual machine. Oh, instead of running it on the hardware, we have a host system. Now we're putting a layer between the host system and our servers. It's called a hypervisor, and you can create as many virtual machines on top of it as you want, right? So now we're at the next step beyond that, where you're either running Docker on the bare metal, which is what we're showing on the right, the blue, right? You're running you've got a Dell server, you've got Ubuntu running on it, and you're installing Docker directly on that, and then you're running containers on top of that, basically directly on top of that host system, but managed by Docker, right? Now, in reality, most of the time we're running Docker, it is running within a virtual machine. So the icon on the right isn't totally accurate because we are running some sort of a virtual machine as the host system. So as long as we're defining host system as either a physical server or a virtual machine, then it holds up. But it's similar to a virtual machine, just no guest operating system, nothing to have to worry about in terms of, as long as Docker is running, you should be good. All right, now, Docker 101, so how do we get started, right? If you, after this webinar, you want to start poking around and try it yourself, a couple of things that you're gonna want to know. It's easy to Google this stuff, but at a high level, there's three pieces that I want to talk about. Really, the most important one, the only essential one, is this first one, the Docker file. That's the text file, basically defines the basic minimum requirements for creating the container, right? So the Docker daemon uses the Docker file to create the container. The container, and I have some examples, so I'm just talking high level right now. The Docker file pulls a particular container image. So if you want to use an image that exists today, Alpine Linux is a pretty popular one. You pull that image in, you define your working directories, and you define the source control that you're pulling down from, some other environmental variables or other pieces that you want to include as part of that container. But once that's built, you've now got your lightweight standalone executable package of software, right? That's the container, and it really depends upon the Docker file. These other two, the requirements file and the Docker Compose, are optional, but that in the kind of standard Docker world, at least the requirements is something if you're a developer already or you're familiar with what a requirement.txt file is, it's always a good thing to include, so that you've got a good, clean list of what your app dependencies are, and you can pull those in, and as you change those app dependencies, all you have to do is update the requirements.txt file. So in this case, our Docker file will be referencing the requirements file and pulling in our version of Python or Flask or whatever it is that we're using. The last item here, I'm not going to talk too much about it because it's used less and less today than I think it was a few years ago, is the Docker Compose. This is really important for managing multi-container workloads. So you can imagine you've got a N-tier application today, you've got a web tier, app tier, database tier. Right? You're going to create a container for each one of those tiers, one for web tier, one for app, and one for database, for example. You need the Docker Compose file to map the services and create basically the framework for exposing the web to the app to the database, right? So that Docker Compose file helps you manage your individual Docker containers, each one of which are created by a Docker file. So in the example I just gave, you'd have 3 Docker files, one for each one of those tiers. The Docker Compose file would pull them together. Right? Now, here's an example of a Docker file. It's fairly trimmed down, right? You're not taking on Amazon with this, but it is a pretty good reference for it. So from Python 3, so pulling in Python, in this case it would be version 3. We are creating a directory that we're calling code. We're establishing it as the working directory, and we are copying our requirements.txt file into it so that we can use pip and install those application dependencies. So pretty slimmed down, pretty trimmed version of kind of the basics to create the image. But you'll get a container at the end of this that you could deploy. I guess it really depends on what you would ultimately pull down from your source control and bake in here, right? You'd probably want to do some sort of like a print hello world or something in here also, but again, not necessary. Next is an example of a requirements file. So I'm not going to spend too much time on this. This is just if you're already familiar with what that document is, but in this case, we've got a Django, so Django 2.0, and Postgres 2.7 are our requirements here. So those will be installed inside the container per the Docker run process, right? The last is this Docker Compose, and again, I'm not gonna harp on this too much because it's really not used less today than it was previously. But basically, here's where it's defining the services that we're going to be using. So we have a database service or DB service and a web service. So DB is defined here with the image, the standard Postgres image here, and the web image, the web service, is outlined here. And we're going to expose it on port 8000. We're going to make sure that it's running, it's exposed to 0.0.0 on port 8000, that we have a volume that's in the same directory as the rest, which is within our code volume, and also that it depends on our database image, right? So it's ensuring that the web, as part of the application, you're going to develop some sort of a connection string that it depends upon that database image being created. Right? Again, this is only for multi-container workloads. So now we've got some idea of how to create the Docker image, right? And now we need to figure out how to run it, because again, running it on your MacBook can be satisfying, but it's not probably why you get paid or why you want to build this thing. It's so that you can expose your brilliance to the world, right? So a couple of services here in AWS that are relevant for containers. And I'll go through the acronyms because the acronyms can be tough. So the first one is Amazon ECR, Elastic Container Registry. The next is Amazon ECS, Elastic Container Service. Next is Amazon or EKS, Amazon EKS, which is Elastic Kubernetes Service. Next is Amazon AWS Fargate, which is well, I'll get into that. And then we have Amazon EC2, which hopefully you're familiar with, but basically it's the managed instance service in AWS. It's a virtual machine. Right? So Amazon ECR, very important. Basically, it's your container registry. So what that means is, and it's very similar to Docker Hub, right? So if you Google Docker Hub, it's the same kind of concept. You create your image, but in order to have your images not just sitting on your laptop, but actually somewhere where it can be accessed and tested by Jenkins or something else, you want to push it to Elastic Container, a registry that can be referenced by one of these orchestration engines. So the registry is basically a list of all the images that you've published. The images are contained there in the registry, and you've got some tagging mechanism where you're adding new tags or you're adding a tag to the container or containers based upon the latest iteration of your code. All right, so that's ECR, really important. The next three, Amazon ECS, EKS, and Fargate, are for running the containers. And I'm going to get into detail later, so I'm not going to drill into it now. But the last item here is EC2. So you can technically run, and this is before all the orchestration engines came about, you can stand up a virtual machine or an EC2 instance. You can install Docker on it, and you can install the containers, right, and run the containers. You're going to need to make sure that you've worked out the networking side so that the web server is exposed on, let's say, port 80, and then port 80 is exposed on the underlying EC2 instance, so that they're mapped together, statically mapped, and so then when a request comes in, your EC2 instance knows how to direct requests to the container that's serving content on port 80. Right, so that's not recommended, but it does fit certain circumstances where you can't use one of these other engines. So this is a pretty good breakdown. I did not make this. I got from a Medium article that references at the bottom of this slide here, but basically goes over those three management or orchestration services that I talked about before. I am going to get into them on detail, but at a high level, ECS is Amazon Docker as a service. It's basically how to run Docker, but they add a lot of the difficulty of running a complex Docker scenario without having to install all the components required for managing Docker containers. A little bit different than just installing Docker on EC2 instance. This is actually an engine that will help you scale up and scale down and pull in dynamically new containers as you publish them. Amazon EKS, Kubernetes, right? Kubernetes is a big word today, and for good reason, right? It came from the Google Cloud or Google's Borg project, and has a lot of really cool tools if you require them. In some cases, there's Occam's razor. If you don't need it to be more complicated than just a container or two, maybe Kubernetes is overkill for your workload. I don't want to say that definitively. I'll get on the soapbox later and give you my opinion on it, but there's lots of opinions, so it's just one among a whole lot of others. And then Amazon Fargate, which is kind of the trimmed down. If you're at a bowling alley and you put bumpers in the rails in the gutter, right? Fargate is sort of the equivalent of that, right? You have a container. You don't really want to spend too much time or learn too much about how Docker really works, but you just have a container and you want to push it up, and or maybe it's a service that only requires a couple at a time. Fargate's a great fit, and it's a service that's getting a lot of attention in AWS. So here is Kubernetes. It's a pretty good diagram, I think, and shows how the service works. Again, Kubernetes is the engine overall. EKS is the Amazon implementation of Kubernetes. So they've taken a lot of the difficulty out of implementing Kubernetes. You still have to know the right levers to push, and you need to know, rely on a trusted partner like a Rackspace to help make sure that it's still configured in AWS constructs the proper way. But a great service for running more complex container workloads. Basically, at a high level, Amazon is going to handle everything on the left-hand side. This master node piece is what the EKS service does for you. They'll set up the scheduler, the API server, the controller manager. They'll set up a cluster of 3 nodes, master nodes, that are basically the Kubernetes service. Your job is to supply the containers and make sure those containers are properly populated as deployments and services using the pods. The pods, in this case, are going to be what's the wrapper around your container. So you supply the container, goes in a pod. Pods are a part of a deployment, and the service is then what you expose through a service like an Amazon load balancer, an ELB, one of the ELBs. So a great design for running Kubernetes, and again, Amazon takes a lot of the complexity by handling the left-hand side. Your job is just to supply the containers, but also if you're going to make changes to the cluster, let's say you want to increase the worker node count that's hosting your containers, from 2 nodes to 4 nodes to 6 nodes, and you want to do that manually because of reasons. But then in another environment, you want it to be able to auto-scale based on CPU or based on a depth of a queue, or based upon the time of day, right? There's a million reasons why you'd want to scale them up and down. You can manage that scaling using a kubectl file, submitting it to the EKS API, and updating that service in real time. Now, if that was too much, and you're really looking for something that's a little more straightforward, we can talk about Swarm, or which is Docker Swarm, or ECS. Right? They're not exactly the same, but I'm saying they're equivocal here in this case. And the diagram is showing the Docker tools, but these tools map pretty cleanly over to AWS tools. So over here on the right-hand side, we have Docker Hub. Right, Docker Hub I mentioned earlier. The ECR, Elastic Container Registry, is pretty similar. Right, you can do a lot of the same sorts of command line for ECR here. But similarly, what Amazon is providing the ECS service is this portion up in the top, the internal distributed state store. Right, so they're creating 3 manager nodes, just like with EKS, but they're different of course. 3 nodes that are distributed, they're highly available, they're part of a cluster, and they're managing the metadata and the configuration information about how you want your nodes distributed, how you want your containers distributed, and how traffic is routing to those containers. So less complicated in a lot of ways than I hate to use the word complicated, but I am going to use it. I'm sure somebody objects to that. I should say it's a little more simple than Kubernetes, because you create a service. The service points to task definitions. Task definitions are, the service is what you expose externally. The task definitions are basically the rules for how you want your containers to run within that service. And then there's a task for a task definition. The task is similar to the pod in the sense that it's a wrapper around the container that you expose, right? So, but in this case, and I'll go back to Rackspace, right? We have a lot of customers. Until EKS came out, we had a lot of customers running on ECS, where you're exposing containers through this ECS engine, through a load balancer, or maybe some other type of service. And then lastly, I know this is a little small, so zoom in if you have to, but this is the Fargate service. And the really salient point here is that on the left, this is ECS. So we just got through talking about ECS. This is another diagram showing the same kind of thing. You've got the AWS managed portion up here at the top. You've got 3 EC2 instances, and in this case, there's 4 containers per EC2 instance. In this case, right? There's a lot of flexibility there. But what Fargate is addressing is the complexity still with managing EC2 instances with Docker. In some cases, that's overly burdensome for what you want to do, or it's creating some sort of a problem. So this isn't a problem, but it can introduce problems. Let's say you have to join your EC2 instance to Active Directory, or you have some third-party authentication system, then you need agents running on the instances, and having them run on virtual machines or EC2 instances is overly complex and annoying, and you really just want to run a couple of containers. It's very spiky workload, and you don't want to deal with EC2. Well, enter Fargate. Fargate is a great option for, you can see on the right-hand side now, there's no EC2 instances. It's strictly the containers, and the AWS Fargate service is just saying, listen, you have a load balancer. You set up the load balancer. We're going to do all the heavy lifting of connecting these containers to the load balancer and making sure that they're exposed on the appropriate ports behind that load balancer. Right? You don't know what's going on in the background. You probably don't want to know what's going on in the background. It's a great service for very particular workloads, but it's not always a good fit. And I have had customers go in both directions. Start on Fargate, go to ECS. Start on ECS, go to Fargate. Fargate sometimes can be expensive if I should say it could be more expensive than running ECS because it's charged differently. ECS, you pay for the underlying EC2 instances. With Fargate, you pay based upon CPU and memory and some other things. that are involved. So it's a little more complex, and for some workloads, particularly static workloads that run a lot of simultaneous containers, Fargate may not be a good fit because you're being charged in a way that you would be charged less on ECS. But again, a little bit more of a simple design. So I moved from EKS, ECS, Fargate in order of sort of complexity, from most complex to least complex. Now, I know you're probably sick of me talking, so I'm going to take a little break, and we have a case study that we want to go through. This customer did engage with Rackspace to go through an exercise in moving to containers, and I will stop talking, show the video, and then I'll jump into the case study.
TotalTrack's working with Rackspace is accelerating our ability to deliver the cloud for our customers. What TotalTrack does is automate the use of forklifts in warehouses.
The fork trucks are doing lifting and shifting all the time. They're lifting pallets off the end of our packaging lines, bringing them down here, staging in our warehouse, and then they get lifted right back onto truck trailers to shipment to our customers.
What we do is equip the forklift truck with a small device that measures how fast you're going, where you are, if you hit something.
There's a upward-facing camera that looks at optical placement markers to figure out where the unit is located in the warehouse down to several inches. It allows them to track safety and maintenance issues, as well as any accidents that may occur. Historically, our customers used on-premise servers. Each customer had their own instance of our software, which made it difficult to perform updates to run maintenance on them. We realized we couldn't just lift and shift the application into the cloud because it wouldn't be scalable. Rackspace helped us come in and use a containerized application so that as we scaled up and added more customers, it would be easy to add more computing power and resources.
The fact that the TotalTrack software is in the cloud definitely enhances the user friendliness of the system, because that enables them to make software updates seamlessly, transparently, so it doesn't affect our operation at all.
What Rackspace has enabled us to do is to deploy our customers much more quickly, so it's gone from 3 to 4 days to 3 to 4 hours.
The Rackspace professional services team was very helpful. They brought with them a wealth of knowledge. They were able to guide us in the right direction.
So leaning on those experts within Rackspace, we're able to accelerate the transformation from, a year or more to a month or two.
Now that our deployment process is automated, we can focus on what our core strengths are. We can focus on new features for our customers.
Awesome. So, TotalTrack. Basically, they took you through an overview of how the business works and some of the advantages that came out of moving to containers. But taking kind of a step back, before we made the video, was looking at the design they had for their application. They were originally a Rackspace customer and engaged us to help them make the move into the public cloud, and also at the same time to take advantage of containers in some of the ways and for some of the reasons that we've talked about, and I'll get into those very specific reasons. But some of the problems that they started with was problems a lot of software development, a lot of software companies have, which is how to push new releases, how to update the application, and how to deal with, and maybe some of this isn't container related, but how to deal with local installations. So I'm going to focus on those last two, the annual updates and new releases. Like I mentioned in the very beginning of this, it's about the developers, and it's about making it easier for you to go from concept to deployment without a whole lot of barriers to entry there. So the two major pieces was product updates and time to deploy. So Total Tracks is obviously tied very closely to the hip with federal regulation, OSHA, right? There are regular updates that come as part of what their software provides, and there's also updates that are feature related or customer related, custom configurations or security releases or a whole lot of things that you need to push. So they are particularly they have the OSHA side, the government side as well. So a lot of schedules to keep track of, and it created a lot of problems for them in their current design, which was basically using a virtual machine to host customers. I have a slide here on the old architecture, but just to get some context. Product updates were a real problem, and time to deploy. You heard in the videos, 3 to 4 days, 3 to 4 hours, right? Makes a big difference when you're trying to roll out a new customer, and if you make a mistake, then you have to start that 3 to 4 day process all over again, right? So the original design was VMs were configured on an as-needed basis. So they let's say they are their first customers, stand up a virtual machine. Use basically virtual host to route the customers on that virtual machine, and fill up that virtual machine with another 4 or the 3 after the initial first, and then you get another virtual machine when you get another customer, right? And in the beginning, wasn't much of a problem, but of course, as you're scaling, that process stinks, right? It takes forever, and it's hard to track, and then you have to match your versions of your application, maybe proximity to the customer. It's just not a very good way for rolling out updates and tracking how you're managing your customer's environment. Took too much time, was costly because the cost didn't match the actual utilization, because let's say you had one single customer, but you had to get a whole brand new virtual machine for that one customer. You may not fill up that virtual machine with other customers for months and months or even years, right? It just really depends on what you're doing. So new architecture took advantage of the ECS service, so the mid service, not Fargate, not EKS, the ECS service that uses underlying EC2 instances for managed containers. So all customers were directed to a single application load balancer. That application load balancer provided the application delivery, basically the endpoint for all of the containers behind it, and it managed the dynamic port mapping back to the containers on the EC2 instance. So what that means is, right, everybody's connecting in, for example, on 443. And let's say the load balancer is doing SSL proxy or offload, and then forwarding requests to the back-end containers on port 80. Well, you've got a lot of EC2 instances back there. Let's say they're all open on port 80, but you also need to make sure that that the containers are also listening on port 80. But you've got multiple containers on the same EC2 instance. So a lot of the value in going with an orchestration engine like ECS or really any of these is that Docker or ECS will handle that dynamic mapping between the external port, which is port 80, and the actual port that the container is on, that's actually set to on the local EC2 instance. And not having to manage that is the real value of running containers on a managed service like this, rather than installing them on an EC2 instance. You're going to have to worry about all of that if you're basically standing up a virtual machine and adding containers to it. So that's a key win there in terms of the new design. And as you can see, it's also easier to scale, right? So rather than going and hunting around for new EC2 instances and trying to fill them up, in this case, all you have to do is create a new service, right? I mentioned services before, but just real quick, you have a new customer, you create a new service. That new service has task definitions and tasks. Those are probably going to be the same for most of your customers, but of course it depends whether you use custom containers for each one of your customers. It's probably pulling in custom data from some external data store, from a database or something else like that. So you can maybe do an identical service for every single one of your customers, but at least every customer is isolated on their own container. It's scaling differently, so maybe you have different tiers of service. Maybe some customers that needs to scale up and scale down because they have a spiky workload, versus others, they're never going to use more than 2 or 3 containers at the same time. All right, we have a question here: does ECS meet PCI compliance standards? So the answer is yes. You can support PCI workloads in using ECS. You have to do it the right way, of course. That's where Rackspace comes in. But yes, absolutely, you can do this. All of these, I believe even Fargate supports PCI compliance. In fact, I'm fairly certain it does. Your big requirements of PCI is going to be encryption at rest, encryption at transit, and logging and intrusion detection. So some of those pieces are outside of this, but the major pieces here would be contrary, Jay, to the example I just provided, which is listening on 443, but offloading SSL at the load balancer and just forwarding to the containers in clear text. That will not fly for PCI. You need to have encryption, in transit throughout the request. So in that case, you would actually need to put certificates on the container. So in that case, it would be part of your some part of your Docker file would include a way of pulling certificates or just statically assigning certificates to your container, and so that the containers themselves are also listening on 443. But yes, absolutely does, and we have e-commerce customers who use ECS or containers in general all the time. I should say one of the big differences between Fargate and ECS is, again, that underlying EC2 instance. If there's no EC2 instance that you need to monitor, in some cases that's great, because now you no longer need to worry about patching Linux, right? Because if it's serverless, right, Fargate is a serverless service, there's nothing to patch, right? That's on AWS. You don't have to worry about that. What you are going to want to make sure you can do is, for logging or auditing purposes, you're going to want to have some way of ensuring that you're capturing, intrusion detection events at the container level, and not all kind of traditional IDS services support containers yet. So that's one thing to be aware of, if you want to manage that, or if you want to be able to capture that container level traffic, you need to have an intrusion detection software service that supports container traffic, not just EC2 traffic. So back to the total tracks example, the impact for those guys was huge, right? And we have a whole video that describes it, but speed to deploy, right? You can, right now on your laptop, you could copy and paste the Docker file image that I had earlier. You can create the container, push it to ECR, Elastic Container Registry, point ECS to it, or even Fargate, and even simpler, Fargate to it, and you can expose the service right away. And then once you've got that set up, all you have to do is push a new version, new container, the whole pipeline set up for pulling that new container in. Well, I should say it's not automatically set up. You do need to set up some way of pushing, right? You're probably going to want to run some tests on the container before you expose it, but once it's in ECR, you can have Jenkins, some sort of a webhook or Lambda function or something, kick off a unit test on a container passes the test, then it is approved for staging or production, and then you can get it in line. But there's a whole lot of easy automation you can include there, and creating that Docker image is generally, as long as it's not a huge application, and a huge application in a Docker container is sort of an anti-pattern anyway, because you're supposed to be breaking them up into their own little components. So in reality, it shouldn't take that long to create the image anyway. So speed to deploy meant more money. Streamlining product updates, what I was just talking about is, you create a new container, new design, and you can keep pace with the regulators. And the higher reliability. So before the first design, the virtual machine, VM goes down, you're sort of stuck until those have been recovered. I'm sure, there's a backup strategy, but it's always better to recover in real time with some sort of automation in place rather than recovering from backups, of course. So reliability meant that they could provide higher SLA to their customers, and of course, I'm sure for auditing purposes that was a big benefit. So it's my last real slide. Key takeaways. So for container adoption, it's developer focused. It should be a good fit for allowing more agile development. Agile comes with its own connotations, but it's supposed to be a really good fit for that type as opposed to the waterfall methodology. There's no operating system to talk about, and if you're to be concerned about from a developer perspective, in Fargate, there is no operating system, period, that you have to worry about. And the Docker file is key. So if anything, if you want to get started today, I would Google Docker file, pull down an example, install Docker on your laptop, and start building containers. In terms of container management, the jury is sort of still out, right? I mean, there are a lot of options out there. Kubernetes has pretty clearly won the container wars discussion. It offers a lot more features than the others, and it's supported on all the major clouds. It's supported on obviously Google. It's sort of their signature product, but it's also on Azure and AWS, and all of those clouds are involved with development and making sure that their native products, their load balancers, their other services are compatible with the Kubernetes engine. So many options. Really, the choice comes down to service complexity and the patterns of your application. So if it's a single container, Kubernetes is probably overkill. I'm sure somebody would disagree with me, but it's overkill, right? And if it's a single container and it's really kind of only running a couple containers at a time, Fargate's probably a great fit. But if it's a lot of containers, but it's the same one, and you do have a good degree of scaling, ECS is probably a good fit. So that's a good benchmark to start with. I'm sure someone will tell me I'm wrong. But in terms of today, that was what I was going to talk about. We do have a couple of questions, but I don't have any other slides to present. I think we have a pretty good overview of what a container is, why they exist, and common use patterns in the engines that are out there. So a couple of questions that have come in. One is, what applications workloads are ideal for containers? Can you name some workloads not ideal for containers? Yeah, so this is a question that comes up pretty regularly. And I think there's still lots to be discovered here, but as a general rule, containers are supposed to be ephemeral, right? They're kind of they're the epitome of the cloud in that they're supposed to be ephemeral. They're supposed to be cattle, not pets, if you're familiar with that analogy, right? So they're supposed to be scale up, scale down, throw away, no persistent data, nothing stored locally. And so taking that logic, you can apply it to certain applications. So a great fit for web servers, a great fit for stateless application servers, not a good fit for stateful application servers, not a good fit for file systems. They can be, but generally they're not if you're following the general mantra that they're ephemeral. So file systems generally, if we're talking about in AWS world, you're going to want to use EFS or FSX, depending upon your containers. But EFS is we have. I should say I work on container workloads with customers who are using containers to scale up and scale down, and they're mounting to Elastic File Service, which is basically a managed Linux file system that can mount to containers, and it's part of the Docker file that it will mount to the EFS directory on the local mount, local drive, and it's accessible over the network connection from EFS. So that's a great pattern. But again, you don't want that file share on a container generally. Another pattern, another question that's come up is, our database is a good fit for containers. And originally I said no, never, don't even think about it, don't ask me again, what a silly question. And then I realized that I wasn't as smart as I thought I was, because there are some examples where it can make sense, particularly for development, right? Again, I started this by saying you should be able to do everything on your local laptop that it will be running in your enterprise data center on Ubuntu server. And that works as long as you can also run a version of Postgres locally, right? Because you have to run it against the database it's going to be running on. So in that case, that would be a good use case for running a database on a container because that's running locally. I'm sure somebody could make the case that you could run it in production on a container, but I would say that it really doesn't fit because when you look at how containers are run and you look at how important it is for a solid, low latency connection to your database, and the fact that it's much, much, much harder to scale a database than it is to scale containers, I would say you should leave. You should put databases on their own standalone, non-Dockerized, non-container workload, and I think it's really hard to argue with that. Let's see, another question. Does AWS have any secret sauce for container management? Well, I don't know about secret sauce. I mean, they've got a good pattern. They've got, they accommodate the big services that are out there. There's nothing specific in AWS for containers. I mean, they've basically taken a lot of what's in the open source community and made it palatable, console-based APIs and SDKs and whatnot that you can use. But there's nothing specific in AWS. There's no AWS container platform aside from Fargate or ECS, which is basically they took the Docker framework and built it into their engine. So, and I think this is probably something I should say that at least this was true a month or two ago, that there's more container Kubernetes workloads running on AWS than any other place. So that does say quite a bit, right? I mean, Amazon does have a strong platform for Kubernetes. What impact does this have with a continuous integration process? So if continuous integration is the goal of a developer, right, having some way of running an agile development process where you're pushing regularly, right, it does do a lot because it cuts down on unit test failures and QA failures because the containers should match your experience locally with what you have in the cloud. So yes, it should have an impact, and it means that you should be able to, rather than having to use some script to build a package on an EC2 instance and then test it in a staging environment and then do a blue-green or a rolling or something else like that. You've got containers. I mean, it doesn't fundamentally change the CI/CD process, but it does streamline it because I'll answer this in a more concise way. It cuts down on the variables and it cuts down on the opportunities for failure because it's its own standalone little package, and so it doesn't, it's not going to fail because in staging you have, Python 3.5, but in production you have 3.7, right? That's all going to be packaged up in the container. You're not going to have that problem. Let's see. And the last item I see here is, what's the best way to get started using containers? So the best way to get started using containers, this is how I got started using containers, was install Docker. It works on Windows and Linux, so install it locally. Go and Google a Docker file example. Familiarize yourself with the command line that you need to use. Test out a really simple hello world, just printing hello world to the console, and then, or not to the console, but to the returning hello world, and then and designating the port on localhost that you want to have it run on, and then try to stand up the Docker container, Docker run. There's some commands you want to include there. So Docker run will get the Docker daemon running and exposing the container on your workstation, and then pull up a browser and navigate to localhost colon whatever port you're running the container on. That's how I got started. We have another question. Would you say AWS Fargate is production ready for the enterprise? Man, so yeah, that's a good question. So the answer is yes. It is ready because it's passed a muster with a lot of compliance standards. They've focused on it. It's probably the closest thing that AWS has to their own container service, if you will, because they're it's serverless, right? So they're managing it all in the back end. I would say Fargate is because for some workloads, it is it's only required on very off circumstances. You've basically let's say you've taken a monolithic application, you've broken all the pieces out, but one of the functions in this application that you have is rarely gets used, right? But you have to have it because it's got to be, and you don't want to have to. But let's say, for example, that you have 10 of these services or 20 of these services, and they're all kind of snowflakey in their own little way. Well, you can put those all as Fargate tasks and expose them as service without burdening what the other engines that you've got that are really taking the bulk of your enterprise workloads, right? So it's a great way of taking a function of your application that doesn't fit well in like a Lambda or a cloud function or whatever we're using here. It's a great fit for those very kind of infrequent or low-level jobs, and there's nothing prohibiting it except. And your question was specifically around enterprise, and I sort of alluded to this earlier. If you have a requirement that everything be Active Directory joined, Fargate ain't going to work, right? Because there's no EC2 instance. There is, whether there is or it doesn't matter. You're not going to be able to join it to your Active Directory, right? So if your enterprise requires that or has another requirement that has, let's say you have some sort of a change management process and you can't have a service that is not tied to a VM in some way. You're going to have to explain that Amazon has this amazing magical service that runs containers, but you don't really know where they are, but you promise them that it meets PCI standards and it's really safe. AWS has plenty of documentation around how you secure them and why they are safe, because you use a lot of methods that are arguably more safe than standard enterprise solutions. But if it's Active Directory or the highway, then maybe that doesn't fit. Hopefully that answers the question. I think we're getting to the end here. I think that is the end of my presentation. I will hand it back to the team here. But thank you, everyone, for joining. Thank you for the questions. And hopefully you'll have some questions and you'll want to work with Rackspace on your containers. Thank you so much.